Hey class, as you work through the engineering design process, you get to a stage where you have to decide on the best design. So how do you decide what is the best design? And what is the best design for an engineering project? Well, today's lesson, we're going to give you some tips, tricks, and solutions to try to answer the question, what is the best design? As you move through the engineering design process, you define the problem, you brainstorm, you research, and you develop lots of solutions. As you move on to the prototype stage, it's often important to pick one design. So how do you pick the best design? It's often easy just to pick a design that you like. However, that's not often the best design. So we're going to take a moment to discuss making good design choices. When you started the design process and defined the problem, you listed the features that you wanted, you listed the criteria or the requirements for the design, and you listed the constraints or the limits of the design. If you're working with a customer, it's often important to really listen to the customer and really tune in to their desires. Don't get me wrong, many successful companies manipulate customers into wanting something they don't think they want, but that's a conversation for another day. So as you reflect on the features, criteria, and constraints that you listed at the beginning of the process, that list will help you guide your choice. First, look at whether each possible solution meets your design requirements. Consider solutions that did a much better job than others and reject the ones that did not meet the requirements. In addition to design requirements, you probably have some features that would be nice to have in your solution. Those are things that are not quite as important as your design requirements, they're just desirable. Often, they're not mandatory. Some of your possible solutions might include some of these nice to have features than others, and that is a possible reason that they might be better. Can you think of some features that are nice to have and are desirable, but are not necessarily mandatory? No matter what you're designing, whether it's a robot, a lamp, or a toy, there are some criteria that apply to virtually every design, and good designers consider them in every solution that they choose to implement. They are elegance, robustness, aesthetics, cost, resources, time, skill required, and safety. We're going to take some time to break down each one of these 8 areas. An elegant design solution is simple, clever, or even ingenious. It might have fewer parts to wear out or fail. It might combine solutions from different areas in an inventive way that's not seen before. All good designers strive for elegance in their designs. Can you think of some examples? For example, find 2 items in your house that serve the exact same purpose, like 2 cups, 2 forks, 2 plates. As you compare the 2, which one is more elegant? Which one's simple? Which one's clever? While being functional is an important design criteria, elegance is one as well. The next criteria is robustness. A robust design is unlikely to fail even when used in conditions more severe than it was designed for. Usually it's sturdy, resilient, perhaps it bends but does not break when it's under hard use. As a teacher, I'm well aware that some items that were purchased for student use were not designed for the robustness of student use. Can you think of some products that are designed to withstand severe and extreme conditions? Another important design criteria is aesthetics. People prefer a solution that is tasteful and pleasing to look at. Can you think of a product that was tastefully designed and pleasing to look at? If you can, that design has good aesthetics. Cost is a very important design criteria. It's important to understand how much the product will ultimately cost. It's important to understand whether or not the target user can afford the solution that was developed. And also, you have to make sure that if you design a prototype, you have enough money to build that prototype. While there is a market for luxury brand items and common good items, it's important to understand how cost can impact your customer's ability to purchase your product. The next criteria is resources. Do you as the engineer have all the materials and equipment you need for your engineering product? Will you be able to obtain them quickly at a very low cost? Resources and cost are very intertwined. A very important consideration is time. Do you have enough time to complete the design and make it before it's due? Do you have enough time to do additional research and fix problems? It's very rare for a product to be developed correctly the first time around. In the engineering design process, meeting deadlines is essential. Another criteria is skill required. Do you have the skills to build and implement your solution? Can you learn those skills in the time available? Or is there somebody else that you can use as a resource that has the skills that are needed to help you design the product that you are trying to design? And lastly is safety. Is your solution safe to build, safe to use, safe to store, and safe to dispose of? Consumers are very conscious of the impact of products on the environment, so it's important to make sure that products can be recycled appropriately. In addition, safety is also something on consumers' minds because unsafe products make it on the news and are often subject to recalls, which can be expensive to the company. In addition, some products have restrictions on the age of the customer that is supposed to be allowed to use the product. Overall, the universal design criteria are important when designing any type of product. They are elegance, robustness, aesthetics, cost, resources, time, skills required, and safety. So having taken a look at the requirements, the nice-to-haves, and the universal design criteria, how do you decide which is the best design? Well, a decision matrix is a very important chart that can be used to help you make the decision on which design is the best design. It may be obvious which solution is the best, but more often than not, it helps to compare the solutions in a design matrix. A design matrix is a chart with your requirements and criteria on one axis and the different solutions on the other. Using a simple numeric evaluation scale, you can rate each solution against one of the criteria. You total up the columns and see which solution is best. Let me show you an example. Here's an example of a decision matrix. Across the top, you have the different solutions that you've come up with. Down the side, you have the different requirements for the design. Then what you do is you give each solution a value, a rating score, based on how well that solution meets the requirements on the left. And then ultimately, your solution gets a final score. By using that final score, you then can determine which solution is the best solution to your problem. In the solution here, solution number 3 has a score of 8. Solution 4 has a final score of 5. So as you try to decide which solution best meets the criteria and constraints, by using the decision matrix, can you see which solution is the best solution to pick? Well, by using the decision matrix, this solution number 3 is the best one to choose because it best meets the requirements and the criteria that you've set for your product. So hopefully you can see how the decision matrix is a valuable tool in evaluating the products that you've designed. Lastly, sometimes you can pick a criteria that can serve as a tiebreaker. It must not weigh out some of the must-have design requirements, but sometimes that tiebreaker can help you make the decision. You can have on your left column as many categories as you want. I'm just showing you an example of one that you might be easily be able to put together. Another way to evaluate designs is to make a simple pro and con chart. You just list the pros and cons for each solution. I'll show you an example in the next slide. The pros are the good things about a solution, and the cons are the bad things. Here's an example of a pro-con chart that you could make. You have your pros, your cons, and your comments. You pick solution idea number 1, list some of the pros, cons, and comments. List solution number 2, pros, cons, and comments, and it's a nice visual way to see the pros and cons of each design idea you've come up with. While a pro-con chart is a valuable tool when evaluating product design, it can be used to help you make other decisions as well. The goal of this presentation was to give you some ideas to help you pick the best design. Hopefully, by using the universal design criteria, taking a look at criteria constraints, using a decision matrix, and using a pro-con chart, you can help better decide which product has the best design. Your next assignment will be to use the decision matrix and a pro-con chart to evaluate the designs you've come up with. Enjoy, and thanks for watching.